Hello everyone, in this video we are going to discuss a number theory problem which came in Bmath Bstat 2016. So let's discuss the problem first. So you have a positive integer d and you have to prove that there exists a right angle triangle with rational sides, okay, and area equal to that given d if and only if there exists an arithmetic progression x square, y square and z square of squares of rational numbers. So these x, y and z may not be like integers, okay, so they can be rational numbers, okay, and whose common difference is d. So you have d here. So this was a nice problem where they are playing with this d. So, and this is like the converse is also true. So it's both ways true. So whenever you see this if and only if statement, you have to prove both ways. Now, first of all, what happens is that you are given with a positive integer d. And now you have to prove that there exists a right angle triangle with rational sides and area equal to d. So suppose let's consider the if part first. If there exists an arithmetic progression x square, y square and z square of rational numbers whose common difference is d. So now if you take the common difference to be d, then y square has to be x square plus d and z square has to be x square plus 2d. Okay, and now given this information we have to prove that there exists a right angle triangle where its sides are rationals and its area is equal to d. So now you know that the area of a right angle triangle is half times the length of the sides containing the right angle triangle, right? So you know that that has to be d. So you have to construct the sides of the triangle. So that is the problem here. Okay, so that's you can think of here how you can like get d. So first your hint would be here. You notice that z square minus x square is equal to 2d. Now if I multiply half on both the sides, so then this becomes d. So now can you bring this into like the two sides containing the right angle of a right angle triangle and show that it's rational? Okay, so this would be your hint for the if part. And for the converse, what you need to do is you have to show that if you have a right angle triangle with rational sides and whose area is equal to d. So since you have a right angle triangle, so let its side be ABC of length. So a square plus b square is equals to c square. Okay, you have this triangle, right angle triangle, and its area is half AB, because A and B are the sides which are containing the right angle triangle, and that is D. So with this given information you have to construct x square, y square and z square, right, and show that they are in arithmetic progression. So what you can do is you can your hint would be to think like a square. So you have here AB, right, so you can like add 2AB. So this is c square plus 2ab and this is coming out to be a plus b whole square and this is coming out to be c square and ab is 2 times d, so this is plus 4d, right? Okay, now you see that the common difference has to be d, so just divide both the sides by 4, okay, and then you will be getting a plus b by 2 whole square and c square or c by 2 whole square plus d. So this would be our second hint, hint 2 for the converse part, okay, only if part. So yeah, try this problem out, pause the video for and try it out, and then if you can't, then do watch the solution. So let's see. So first we'll be starting with the if part. So this is the given information. So this is given to me, and as I told you in hint 1, that is, consider this z square minus x square half equals to d. Okay, so now if I can somehow show, so let's factorize this. So this is half z minus x times z plus x, right? And that's equal to d. And now if these two are the sides of a right angle triangle containing the right angle, so let's see what can be the hypotenuse. So z minus x whole square plus z plus x whole square. So how much is that coming out to be? Z square plus x square minus 2zx plus z square plus x square plus 2zx. So this 2zx, negative 2zx cancels out, and what you have is 2z square plus 2x square. Okay, and what is this actually? So let's look at it. Okay, yeah, this is coming out to be 2 times z square plus x square. Now z square plus x square, so z square plus x square is 2x square plus 2d, right? And that is basically, we know that if we take the 2 common, so we get x square plus d, and x square plus d is nothing but y square, right? So this is 2y square. Fine. And so the z square plus x square is equal to 2 times this is 2y square, so directly let's, okay fine, 2y square, and which is equals to 4y square, and this is equal to 2y whole square. You see, we have the other, that is the hypotenuse, is coming out to be 2y, which is rational. Okay, so these x square, y square and z square are squares of rational numbers, and so you have z minus x to be a rational number, and z plus x is also a rational number, and 2y is also a rational number. So we have a right angle triangle where the sides are z plus x, z minus x, and this 2y, right? So yes, we have proved that there exists this right angle triangle with rational sides and its area is equal to d, right? So we are done with the first part. Now about the only if part. So what about that? So for the only if part, again, if you have used the idea that I gave you in hint 2, let's see. So now we are considering a right angle triangle and with rational sides and whose area is equal to d. So we have a right angle triangle, a square plus b square is equals to c square. where those a, b and c are rational numbers, and its area is equals to half AB, which is equal to D. Okay, and now as I told you, to complete the square on this side, so a plus b whole square is equals to c square plus 4 c square plus 4d. Will it be 4d square? 4d, right, 4d. Now yes, as I told you, just divide it by 4, so you get a plus b by 2 whole square is equals to c by 2 whole square plus d. Now this was your hint for the second one, right? Now we have something like plus d, so this c by 2 whole square plus d. So you see, you need to have x square, y square, z square, which will be in arithmetic progression. So, and this can be one of the term plus d, right? And what can be the other term? So you see, it's like we added this AB on both the sides, so we get plus D. But what we just subtract this AB, 2AB on both the sides. So let's see, a square plus b square minus 2ab is equals to c square minus 2ab, right? And so we get a minus b whole square is equals to c square minus, then this ab is equals to 2d. So this is coming out to be 4d. And now you see, we get a minus b by 2 whole square, right? And that's equal to c by 2 whole square minus d. Okay, isn't that beautiful? We have this square is equals to this plus d, and this square is equals to this minus d. So you see, like c by 2 whole square minus d, then c by 2 whole square, and then c by 2 whole square plus d. So that's your arithmetic progression. They are in their difference is d, which was required here, right? And they are also like the squares of rational numbers. Why? Because this c by 2 minus d, as you can see, c by 2 minus d, this is this quantity here, right? And this c by 2 whole square plus d is this quantity, right? And so what we can do is like this term is that, so a minus b by 2 whole square, and then c by 2 whole square, and this a plus b by 2 whole square. So you can consider this as x square, and this as y square, and this as z square. And you have x square and y square, z square, they are in arithmetic progression. And so we have constructed the arithmetic progression as well of rational numbers. Okay, so see you next time. Thank you for watching. Bye.